Hello learners, welcome to my session. In this session, we are going to discuss about the product tracking in retail supply chains. What are all the methods by which we are tracking the materials while we are doing the retail business through the supply chain, and also shipping out by loading into containers. We will discuss one by one. The first slide talks about the video talks about retail supply chain tracking tools, which is categorized as automatic identification and data capture. So automatic identification technologies, these technologies have enabled multi-channel or omni-channel supply chains. These offer consumer choices in ordering and receiving merchandise. For example, merchandise could be ordered online and mailed to the buyer, or the buyer could call in the order and take delivery of the merchandise in a brick and mortar store. Technical innovations accompanied by increasing number of solution providers make this as an area of charm in the roles of supply chain participants. For example, merchandise formerly bought in a store can be ordered online, and diminishing the store sale and the retailers need for real estate. The same technologies also create confusion among supply chain decision makers. The confusion arises in deciding which of the many proposed options is the correct one which they can choose it for a particular supply chain. Also, the economics of AIDC change continuously, with the cost of implementation declining as technologies become more widespread. Despite the confusion, channel masters such as Walmart and the Department of Defense mandate increased use of radio frequency identification, that is called as RFID, by their suppliers. RFID is a prominent AIDC technology, therefore managers along the retail supply chain, including manufacturers and distributors, must be informed about its applications. The retail industry already relies heavily on technology, so each year a large retailer could easily have thousands of suppliers providing tens of thousands of stock keeping units, that's SKUs, and hundreds of thousands of deliveries to hundreds of locations all around the globe. The size of today's retailers such as Castor, Target, Best Buy, Walgreens, and others has been enabled by electronic digital transformation processes. For any single company, these transactions generate millions, that is, if not billions, of information exchanges in the form of forecast, orders, shopping and shipping, notices, receipt documentation, payments, and returns, etc. The need to track merchandise extends from the manufacturing process to the store shelf. In fact, according to Kerry Pauling, Vice President of Information Systems at Walmart, getting stock through the last 90 feet from the stock room to the shelf is where we often have breakdowns. So, according to his statement, an interesting example of potentially costly losses occurs in grocery stores. Customers often decide at the check stand against purchasing items and they have previously selected. And these may be perishables that, if not returned to refrigerators or freezers promptly, will spoil and become unsaleable. Yet the inventory tracking system has totally lost track of the warehouse of these products. and keeping tabs on such complex high volume processes is daunting. Furthermore, in a global economy, trading partners in many countries are bolstering the need for standards and ensure efficient and timely information exchanges. So this slide provides an overview of selected AIDC technologies, which is addressing technologies, and also related standards. The contents include the following matters. Number one, standards for identification and tracking. And number two is about RFID. And the third one is about the vision for integrated distribution and retail solutions. The low-tech retailing Fred Abernathy is with the Center for Textile and Apparel Research at Harvard University. He has traced the growth of barcode technology as an early AIDC technology. Barcodes, the most common of which are Universal Product Codes, that is UPCs, are the foundation standards for retail chain tracking. Then Abernathy describes the labor-intensive state of the retail supply chain. Barcodes made their appearance. So merchandise was spread around on the store floor, in the back room or in the warehouse. Knowing what was actually selling was a problematic one. Orders were placed 6 to 9 months ahead of the selling season, well before trends in demand could be discerned. Assistant buyers tracked inventory manually, labor-intensive. It is creating a labor-intensive processes. So paper records reflected sales of categories, not individual SKUs, reducing the precision required for effective rendering or reordering. See, the retailer, dispatched by long lead time and information gaps from manufacturers, carried the risk that go with stockouts or surpluses. Before barcodes, Kimball tickets, the small form of the old punch card technology, was the only real mechanization that existed for inventory tracking. These tickets were processed by a form of unit record equipment and were prone to the human error. The advent of barcodes began the shift to automated tracking. In 1973, IBM was awarded the contract by the Uniform Grocery Product Code UGPCC ad hoc committee and the consulting firm McKinsey and Company to develop a barcode technology usable across the industry. In June 1974, at a store in Ohio, a 10-pack of Wrigley's chewing gum was the first item to cross barcode scanner. Subsequently, the retailer Kmart introduced barcodes for apparels in 1983. Others like Walmart followed, bringing the spread of what Abernathy describes as lean retailing. Improvements in computing technology aided and abetted the spread by translating captured bars code data to support merchandising decisions. The initial UPC specialization or the specification had 12 digits, 11 required by UGPCC plus 1 check digit. The check digit protects against errors in reading the codes, and this version is the first and which is shown in the figure which I am going to show you now. Most current US barcodes use this format or symbology. After a submittal, the IBM team was asked to add a 13th digit that could be read without modifying equipment already in the field. This is the second version, which also I will be showing it in the figure. And this addition provided country identification, in effect enabling the widespread, worldwide spread of the UPC. The additional digit will also lead to the European article numbering, that is the EAN, system administered by EAN International, and now it's GS1. and their standards are called as EAN UCC standard, and they cover barcodes, electronic data interchange, that is EDI transactions, sets, HML, XML schemas, and other supply chain requirements. See, as noted later, they promote the standard under the auspices of another organization, EPC Global. EPC stands for Electronic Product Code. In the automated identification space, participating organizations, standards, and products have proliferated and potential confusion factor to those who have not followed the evolution. And there are again identifying 10-digit plus overhead digits. These are for the check digit and identification functions. The EON version has the 2-digit number system code plus check digit, whereas the UCC version has one identifier and one check digit. A manufacturer or the distributor or the retailer can have 99999 SKUs by virtue of their 5-digit product code. Adding to the complexity of the standards, each of these symbology standards has variations for special circumstances. These variations use techniques to shrink the space required for the barcode, enabling barcode or small items. So this is what they use the check, and this consists of here the 7 as the number system, and manufacturing code was this one along with this 01054, and here the product code is also given along with the check code, check digit, which is inside, that is 530107. So this is what the barcode system which was provided. Once a manufacturer, distributor or a retailer is assigned an EPC manager code, the organization is free to assign codes to products. This can be for internal or external use. In fact, some retail merchandise such as an apparel item may have multiple barcodes identities as it passes along the supply chain. An example would be the product code for original manufacturer, and for the another one is for the retailer. So beyond the basic barcodes, as older UCC and EAN formats are near their capacities, standards for the 14-digit global trade identification number GTIN emerged. GTIN has become the umbrella term for all the barcode data structures, such as those in the figure which I showed you, and others needed for other data carriers such as RFID. This number identifies the manufacturer's product version and serial number, where the number uses fewer than 14 digits, and it is padded with zeros, encouraging migration to the uniform barcode length. And the voluntary non-profit organizations, EPC Global Inc. is an independent body with a board of governors from leading supply chain subscribers. The organization had its origin in the Auto ID Center at MIT, GS1 and GS1 US, which set standards are members. EPC Global's mission is to support the deployment of radio frequency technology, and EPC Global refers to this as the EPC Global Network. In 2005, the head of EPC Global US, Mike Miranda, described the role of the organization. Miranda stated, "Standards development is not a destination." He notes that technology is a tool to achieve a business objective, and his organization used 5 elements to promote its mission to the technical community. So number 1 is the electronic product code, that is EPC, the globally unique serial number that identifies items of all types along the supply chain. Then ID system, the RFID system, tags that stores the EPC and the hardware needed to read the EPC. Then EPC middleware, The software interfaces that manage supply chain, read events and handling of the information. Interfaces with EPC information services, that is, and enterprises systems. And EPC, the fourth one is EPC information services, which enables information exchanges with the trading partners through the EPC global network. And discovery services is the last one. Tools that enable users to find data related to specific EPCs. And the core element, the EPC includes items in the GTIN and adds extra digit for unique item identification, supporting what is called item level tracking or ILT. The ILT aids in combating counterfeits, providing product quality documents and better managing inventory. A report in the publication DC Velocity described emerging applications for ILT and the drivers behind them. So beyond the basic barcodes, tagging innovative products such as new CDs and DVDs, so they are easy to locate during their short introduction windows. Documenting pharmaceutical movement through the supply chain. Example, Purdue Pharma shipping tagged bottles of OxyContin to Walmart and a wholesaler. And cost effectively locating hard to find sizes and colors of upscale apparel items before a customer leaves the store because an item cannot be found. Theft reduction for high value goods such as jewelry, rental scales and electronics items. Expiry dates tracking for food items such as cream, cheese, etc. Monitoring temperatures along the supply chain, automatically playing promotional video about the product when a customer picks up a merchandise item in the stores. And in early 2016, the GS1 website reported the continued momentum of item level tagging, ILT. The report noted the need for increased supply chain efficiency and the desire to reduce out of stock issues. So I will show you the figure which shows the components of EPC, and the EPC global refers to this number as a license plate. It can be assigned to objects in the supply chain such as individual items, cases, pallets and locations. It is also compatible with the existing numbering systems such as the GTIN. The manager number is assigned to the companies wanting to use the barcode system. Although the basic 12 or 13-digit barcode systems are familiar to most retail customers, the other barcode formats exist that enable greater returns from the technology. These includes the following things. So you can see that in this diagram. This is electronic product code, this is EPC, and this barcodes examples. So this is the healer identifies the length, the type, structure and version and generation of the EPC in 3 digits. And the manager number identifies the company or the entity. So this is what 48000. And the object class is SKU, the other object identification. This will be in 6 digits. This is the third one. And the fourth one is the serial number tailored to the link being the tagged, that is with these numbers with the zeros and other things. So reduced space symbology, that is RSS, for placing barcodes on small items or adding needed information not available in the regular barcodes while keeping a small footprint. So two-dimensional, that is 2D barcodes that used with or without one-dimensional codes such as UCC, EAN barcodes provide around 2000 characters depending on the format. And this is what 18.3 figure is going to show you. And examples of many available formats are the RSS include, formats include RSS 14 that is RSS limited and RSS expanded, and find application on smaller items such as individual pieces of fruits, cosmetics, jewelry, and so forth. Their appearance is similar to regular barcodes. Some formats have double tap or the two lines of barcode to conserve space. Sometimes the retailer needs to add information to basic barcodes in the same space provided by UCC AN barcodes. So SKUs with limited shelf life such as dairy products and pharmaceuticals are examples and need to include expiry dates, expiration dates also. Other applications include SKUs sold by weights such as meat and the produces items that require tracking, and promotion products eligibility which is for of the coupons. And 2D barcodes. So as shown in the figure, 2D barcodes resemble postage stamps with a variety of patterns imprinted on them. Some applications combine conventional 1D with the 2D data. Such uses described by the 2D barcode company data intro software include income tax returns, mixed SKU packing list, and patent medical records. In these situations, the 1D barcode provides the license plate identifier and the 2D barcode provides the details. So other versions are designed for data capacity or for reading on high-speed conveyor lines. And the 2D barcode examples. Designing systems to read barcodes can be an engineering challenge. So Intermec, a firm offering supply chain automation solutions, recommends different technologies depending on the nature of the item read, the potential for dirt on the barcode, whether the location is inside or outside, whether the barcode is 1D or 2D, and the distance over which the read must occur. Such complexities plus the frequent need for labor to use the technology or motivators for supply chain managers to return to RFID technology. Although barcode is considerably less expensive and in some instances can be used in conjunction with newer technologies, RFID applications already appear around us in the form of automatic car locks, road and bridge toll collections, subway fare collection, library materials checkouts and returns, animal identification microchips, and human implants of various sorts. Successful RFID implementation depends on collaboration among supply chain trading partners. For the distribution centers or the retail store to use RFID, the manufacturer must place tags on its pallets, cartons, or individual items. What level pallet, carton, or the item will vary depending on item value, the cost of implementation, the need for control, and other factors. The most common RFID application in retail supply chain calls for placement of low-cost passive tags. These are part of open loop systems, that is, the merchandise passes from company to company along the supply chain. The tag is passive if it has no energy source. Active tags discussed later and have batteries or other power sources, and they are often installed in closed loop systems confined to a single company or a small group of trading partners. The more expensive active tags are usually recycled for multiple trips through the process. The energy required to transmit the passive tags content is provided by the radio frequency emergency transmitted by the reader. The reader transmits enough energy to cause the tag to respond with the identifying data stored on the tag. The tag antenna length is half the wavelength of the operating frequency. So lower frequencies have larger antennas. The most visible part of the tag, the chip, in fact, is about the size of the head of a pin that can seen as a small dots near the center of the tag. and which I can show you in the RFID tags in the forthcoming pictures. The antennas on the passive tags have different sensitivity to the direction of the reader signal. The tag signal is also affected by metal or liquids within the near tagged product and the location of the tag on the product. Tags should be chosen with these factors in mind, as well as an understanding of how each tag will be scanned and where it will occur. For example, the 4-dipole model, upper right, we can see it in the diagram now, is less sensitive to orientation. With regard to capacity, a passive tag can hold up to hundreds of bits of data. With RFID tags on each case on a pallet, a reader can identify all the cases without a person having to scan each case. Lower frequency readers have a short range of few inches. Higher frequency readers have ranges up to about 30 feet. Then RFID application like barcode system. Designing an RFID application requires a number of considerations that depend on supply chain requirements and system cost. Some of these are listed later. In a typical warehouse application, the reader will be placed at each clock door or portal. The RFID data captured would take place as pallets are offloaded from the truck or rail car. Cost per portal can be in the thousands of dollars, so implementing RFID must be justified by saving in labor and improved tracking accuracy, particularly in large warehouses with 100 or more doors. To minimize this cost, warehouses frequently have separate RFID portals near a group of loading docks. Items are unloaded from trucks into a receiving area and then pushed through or placed on a conveyor to pass through the RFID portal. And the other applications call for handheld readers or readers on lift trucks. These provide added flexibility in exchange for a decreased investment. The same electronic hurdle exists at the store level also. The need to lower the cost of tagging and reading enough so that improvements in labor cost and data utility can pay for the technology. Complicating matters in the fact that a company such as Walmart dictates RFID to its manufacturers. However, the manufacturer may enjoy few direct benefits also. However, the inclusion of RFID tags may result in large orders from large retail chains. Most benefits occur further down the supply chain. So, I will show you the figure in the next slide describes a tracking stock as it moves from the manufacturer to the retail shelf. Active RFID tags include their own power supply, and two categories of these tags have initial power supplies in the form of batteries and electronic grid connection or solar power. These are called active and semi-active tags, also called battery assisted tags. Active tags transmit to the reader unlike passive tags, which use energy from the reader to respond, and the semi-active tag is triggered by the reader but uses onboard power to respond. This increases the range over which it can read it, and the read is also faster because the delay involved in responding is lessened. A speedy response is important if the tag is moving at high speed. Active tags can read at distances about even 300 feet. Often the best applications for active RFID are closed-loop supply chain processes. The closed-loop application takes place in single facility or a company in linked processes shared by trading partners. For an example, an auto parts supplier and its assembly plant customer. The active tags material shipped into its supplier is removed after the part is assembled into an automobile. Another example would be a laptop computer repair facility serving a retailer such as Best Buy, where active RFID tracks laptop location through the repair process. In crossed-loop applications, the tag is attached when the item enters the process and removed when it leaves. Both passive and active tags support capabilities for rewriting data over the life of the tag. A read-only tag, that is RO tag, is programmed at the factory where it's manufactured. No rewriting is possible. So this type of tag finds limited use. Write once, read many, that is we call it as WOM, is written by the user and read throughout the supply chain. This is the most common type of tag, a read, a write, RW tag, which can be written practically indefinitely. Then an alternative passive tag technology called the surface acoustic wave, that is SAW, has advantages over the microchips deployed in today's RFID tags. These chips are used on devices with touch screens and have a number of other applications. SAW chips utilize the piezoelectric effect, which relies on the fact that ceramic substances and some crystals generate voltage when mechanical stresses are applied to them. So the transducer located on piezoelectric material generates a surface wave when excited by the reader's radio pulse. That surface wave is converted into acoustic wave pulses coded to the tag's data. The transducer then converts the waves back into a radio wave and sends it to the reader. The SAR technology has longer ranges, is more rugged, can be used around difficult materials such as metals and heavy liquids, chemicals, uses less power and is more accurate also. And then tracking transit. Total supply chain visibility requires knowledge of where the product is all along the chain, not just in controlled facilities. Visibility requires in transit tracking a capability provided by what are called real-time location system, RTLS. This tracking is not always just for identification purpose, security purpose also. This measures may seeks to ensure that a container from a distant supplier poses no security threat. Monitoring the integrity of the container seal and monitoring for signs of hazardous materials provides assurance regarding a shipment. To this end, the US government has elicited the cooperation of supply chain participants in TPAT or Customers Trade Partnership Agreement terrorism. Those collaborating in this effort agrees to take preventive measures to protect against container tampering. Some products, and particularly those in grocery environment, require a cold chain, and I will explain that in the nearby slides. Chapter 21 and section 21.1 that which I am going to explain to you describes the demanding chains. What are the demands which is needed, how the chains are demanded, and what are all the people, those who are playing the roles. That is what which we will be discussing. Those responsible must be assured that temperature limits are met all along the chain. One way to ensure this is to monitor temperature in transit and warehouse and in the stores. This requires sensors attached to active RFID tags that keep track of temperature exposure as the product travels through its various intermediaries from manufacturer to retailer. Other types of sensors may monitor radioactivity, chemical environment, humidity, shocks and vibration as and when it requires. And the Yoshibumi Kochito of Mitsui company in the United States describes a test implementation of RTLS, and the position at this company is at the time of report was the director at transportation and logistics. His company provided services and financing related to export, import, and offshore trading. The company has pioneered applications with RFID in manufacturing, logistics, and retailing. Mitsui offered a service called SCM Live for tracking material movements in global supply chain. Kotsuka identified the following keys to success in implementing a supply chain visibility application, that is RFID tags data must be generated at the origin where the goods are manufactured. Success requires cooperation among trading partners to avoid disruption and ensure easy use of these RFIDs. The solution must adhere to global standards and involve a blend of AIDC technologies. For example, his solutions include EDI, barcodes, active and passive RFID, and global positioning system (GPS), among others. An infrastructure such as Mitsui's SCM Live must gather data generated by the system. Users must mine the data and put them to work to make decisions all along the supply chain. And Mitsui piloted the deployment of tracking technology. The test was from points of origin at manufacturing centers at Gantam and Sheshan in southern China, across the ocean to US ports at Long Beach and Los Angeles, and then on the inland disease. And this is a heavily traveled path for imports from China into the United States. And the figure which I am going to show you depicts the path across several transportation links. At the carton level, the manufacturer attached both barcodes and passive RFID. Each carton contained 16 individual items, each pallet which was also tracked with the RFID passive, which was held 16 cartons or 256 items. The pallets went into a container sealed with an active RFID tag and an EC security device from SAV Savvy technology. So the device included intrusion detection, environmental monitoring, and weapons of mass destruction (VMD) sensors monitoring radiological, chemical, and biological threats. So this is what the Mitsui supply chain visibility tracking. You can see from here how it is moving. So the containers were read at the portals at the Chinese port of Yangtang, and this was the port's entry gate. You can see that port's entry gates for the inbound container and the gantry crane for outbound containers. And it was likewise read upon arrival in Southern California. But the GPS tracked the containers across the Pacific Ocean en route to the United States. The RFID at the DC portals recorded the containers' arrival at the warehouse. During shipment truck transit, the GPS also tracked the vehicle, making the system aware of which pallets were in which truck. So the trial report concluded that 100% of both passive and active reads were successful. Intrusion detection and real-time tracking was also sustainable transit. When exceptions or events occurred, when the system dispatched notification to supply chain decision mark. Tracking transit, future of product tracking. So this chapter we discussed about the description of life before barcodes and the technologies deployed today. Barcodes economically contain individual product specific information, whereas RFID at considerably more expense allows for the tracking of inventories by supply chain participants on its path to the retailer. This chapter ends with look into the not so distant future for retailing locations. We are going to discuss the future of systems, RFIDs, which is going to available. Now the QR code is also available. Future RTLS system, like many solutions in this space, teams of technology companies have collaborated to prepare the visions of the end-to-end retail location. One such a team referred to their vision as the agile and lean supply chain. So the publication SED just summarized the features of the legal supply chain strategy. This approach blends elements of lean and agile supply chain strategies. Some features of the supply chain included the use of make-to-order demand-driven supply chain technologies to pull merchandise through the chain, and use of different business rules for high-running and less frequently ordered products, passive RFID tags applied at both the items and case levels, intelligent shelf technology, where RFID readers monitor the contents of storage locations in warehouses as well as stores, automatic detection and reporting of out-of-stock items and shrinkage by monitoring the shelf, a warehouse management system that is WAMS to oversee movement at warehouse and at retail store levels. Several applications to translate RFID data into updates for the PMS is cost-effective printing of RFID tags at the manufacturer. Direct feedback to warehouse material handlers when errors in stock put away and picking are made. Automated warehouse cycle counting for inventory. A network inventory visibility system to monitor inventory within and between supply chain locations, creating notifications when expectations occur. So you can see the tag items, how it is available with different pictures, distributor centers, and this is what the vision for the agile supply chain. Once the commitment is made to the item level tagging at the manufacturer, most of the downstream activities related to the managing inventory are automated. The agile supply chain also has the ability to sense shortages at the store or warehouse, and this provides the benefit of maximizing revenue in the case of shortages at the retail level. It also signals to the supply chain when a product is not selling well, calling for cutbacks of in production. However, the cost for RFID tagging are still high. So the use of this technology for low-priced, lower volume products still lies in the future. A lot of improvements must be done in this. On the operations side, incorrect picks or putaways are also signaled. The system can also match actual inventory with what should be there, resulting in the automation of inventory taking, potentially a cost-saving justification for using this technology. So differences between book inventories and actual quantities can be indicator of linkage, poor execution, or the quality problems can also be identified. So these are all the process steps for agile supply chain. Step number 1, and this is the step description. So tag items. An operator scans the barcode to generate passive item tags on a printer, and the tag cases. An operator associate individual items with the case and prepare the shipments. An overcoming order for several cases is filled, order documentation identities, and the items included. And this is happening at the manufacturer's place. This is happening in the warehouse. Receive shipments, the warehouse receives the shipments and the store cases. The shipment is moved to intelligent shelves. Any errors in the shipment are detected, and the WMS captures receipt of proper shipment. And this is what step number 6, pick and confirm order. An order for one case is received. The WMS authorizes picking. A picking error is detected and material handlers are redirected to pick the correct item. The shipment is transported to the store. And at the store, what is happening? The stage in the store back room. The item is tagged for display shelves in the back room of the store and intelligent shelves. Place items on display shelf. The sales occur intelligent display shelves on the store floor are replenished from the stacking shelves in the back room. So the economic case for product tracking depends on the cost of tracking, parts to the customers, the value of the merchandise involved, and also the expected benefits. The visibility provided by using these technologies eases the work of matching supply and demand, particularly in reducing stockouts. This benefit is often subtle and unseen by the potential users. Companies along the supply chain will continue to experiment with innovations in merchandise tracking. This chapter should highlight the awareness of the alternatives and the challenges and opportunities that go with adapting tracking technology to one's supply chain. We are going to the second part of it. Soon I'll finish off this video, maybe a little bit lengthier, but this is the need for the hour, so I'm just expressing it in one particular video. Shipping out by loading into containers. In today's world, retail supply chains have become more complex than ever before. So the retail industry is constantly changing and companies are under pressure to deliver goods to customers faster at lower cost. So the supply chain management processes has become increasingly important to ensure that goods are moved efficiently and effectively from manufacturers to retailers and eventually to the end consumers. And one of the critical aspects of supply chain management is the transportation of goods from one location to the other. Shipping out by loading into containers is one of the most popular method of transportation in the retail industry. In this method, goods are loaded into containers which are then transported to the destination using various modes of transportation such as trucks, ships and trains. There are different types of containers available for shipping goods. Some of the common types are dry containers, refrigerated containers and open top containers. Dry containers are used to transport non-perishable goods, while the refrigerated containers are used for perishable items. Open top containers are used for oversized or bulky cargoes. Containerization is the process of loading goods into containers, and the containerization offers many advantages over traditional shipping methods. It allows for faster and more efficient loading and unloading of goods, reduces the risk of damage to goods during the transportation, and offers better security. Freight forwards play a crucial role in the shipping out process. They are responsible for arranging the transportation of goods from the manufacturer to the retailer. They handle all aspects of transportation process, including documentation, customer clearance, and also the insurance. And intermodal transportation. Intermodal transportation is the movement of goods using multiple modes of transportation, such as trucks, trains, and ships. So intermodal transportation is an efficient and cost-effective way to transport goods over long distances. Documentation part of it. Documentation is an essential aspect of shipping out by loading into containers. It includes flagging, invoices, packing list, and the customs documents. Accurate and timely documentation is critical to ensure that goods are right destination and they comply with all legal requirements. Container trackings. We studied about different types of trackings. Now the container tracking is the process of monitoring the location and status of containers during transportation. It allows for real-time monitoring and the movement of goods and helps to prevent theft and loss of goods and terrorist attacks also. Then the advantage, efficient use of the space. Containers are designed to maximize space utilization and make the most of the available cargo space on ship, which helps to reduce shipping cost. Improved safety and security. Loading cargo into containers reduces the risk of damage, theft, and loss during transit, and as containers are sealed and locked, providing an additional layer of security. And standardization. Containers are standardized in size and shape, making them easy to handle, stake, and transport access across different modes of transportation. transportation such as ships, trucks and trains. There will be crane type and loading type, lifting type, and different type of containers are available. Escalator type, elevator types, and simplified logistics. Container shipping enables easy tracking of shipments, simplifies customer clearance, and reduces the need for manual handling of goods, which speeds up the transportation cost and the process. And limited cargo capacity, which is a disadvantage. Containers have a fixed capacity, which means that larger or irregularly shaped cargo may not fit into them, so limiting the amount of cargo that can be transported. Higher capital investment, investing in container handling equipment such as cranes, forklifts can be expensive and make it challenging for small businesses to enter the container shipping market. Then environmental impacts. Container shipping requires the use of large ships that consume a significant amount of fuel and emit greenhouse gases, contributing to the global warming. And challenges of shipping out by loading into containers. Shipping out by loading into containers can also have some challenges. These include delays in customs clearance, container damage, cargo theft, and problems with documentation. However, these challenges can be overcome with proper planning, communication, and collaboration between all parties involved in the shipping process. The infrastructure requirements. Container shipping requires extensive port infrastructure, including deep water berths, cranes, and container storage areas, which can be expensive to build and maintain. Supply chain coordination. Container shipping involves multiple stakeholders such as freight forwarders, shipping lines, and customs brokers, which can make supply chain coordination complex and challenging. And also the container availability. In countries like India, it is very much difficult to get a proper container for your product. Container availability can be limited during peak shipping seasons, leading to a higher container rental cost and potential delays. What are the opportunities shipping out by loading into containers? Market expansion. Container shipping provides access to the broader range of international markets, so people can trade in the international market, allowing businesses to expand their customer base and increase profits. Diversification of transportation modes. Using container shipping in conjunction with other transportation modes such as air or rail can provide more options for businesses and may improve supply chain flexibility. Increase the efficiency level also. Container shipping enables faster transit times, reduces cargo handling and storage cost, and simplifies custom producers, improving supply chain efficiency. On the whole, in the conclusion, shipping out by loading into containers is an important aspect of supply chain and logistics management. It offers many advantages over traditional shipping methods and is an efficient and cost-effective way to transport goods over long distances, especially in the international trade. Proper planning, proper communication, and collaboration with other parties are essential to overcome the challenges and ensure that the goods are delivered to the right destination on the right condition with the right specialized situations. So, on the whole, this particular video may be length, but you should know about how the goods are tracked with RFID cards or latest situations, what are all the developments in the container trackings, and how to do the outbound shipping documents, and also the containers loading, which is boon to the current scenario people who are doing the business in the global markets. Many countries they want to do business only with the container shippings, so that should be taken care of by the retail players as well as the international suppliers. Thank you for watching this video. We will see you in the next video. Until then, you can learn along with me. Enjoy learning.